Okay, so you can, for this, essentially boil it down to you're trying to connect a situation with a graph. You've done some of this in science, probably with distance time graphs and velocity time graphs. And the first couple of graphs are going to, hopefully you can bring some of that understanding into play here. This first graph just shows somebody wakeboarding. This is what the boarder. This is a graph of what the wakeboarder is doing. You can, obviously there's going to be more than one answer here, and when you look in the textbook to try and compare, yours is not going to be exactly the same, but the things you need to know here are how the shape of the graph relates to the situation. This is a distance time graph, distance time. If you look at the first part here, part A, if you're describing the graph there, it's a line that's not very steep, right? And then it changes to a line that's much steeper. You're responsible for understanding kind of the difference, how the steepness affects what's happening in the situation. What's happening for that first part? What do you think? A line that's not very steep? What's happening? What's happening? Moving slowly, right? I would say that is moving slowly. Its speed is not very much. You probably know from science that if you have a distance time graph, the slope, have you heard the word slope before? What's the slope represent? On a distance time graph, what does the slope represent? Because I think you guys know. It's velocity or its speed, right? We're going to say it's velocity because we care whether it's going downhill or uphill here on the graph, whether the boat's going forwards or backwards or going or coming. That it's not going very fast, then it suddenly starts going faster. And then what happens here? What does a horizontal line represent? It's constant. Whatever this quantity is, a horizontal line means it's constant. Okay, so it means the distance is not changing. It's a constant distance, which means, what does it mean for the boat? If you say the boat's at a constant distance from this is the distance from the start. So if the first part of the graph, they're going away from the start, they go slowly at first, and then they go fast afterwards, right? There's a couple different things it could be. Probably, what's the most likely thing that is? What does a boat do? When it's horizontal, it's not staying at a certain speed. It's actually, this is not changing. Distance is not changing. You might be thinking of if this was a speed time graph. If this is a distance time graph and the line is horizontal, whatever that distance is there, okay, whatever that number represents, it might be 2 kilometers or something like that. That distance is not changing. The boat is stopped, or I guess it could be going kind of sideways, so it's not getting farther away, it's not getting closer, but probably the most likely thing is the boat is stopped. So it's going slow away from the start, going faster away from the start, stopped, going fast away from the start. What happens here for this section? For this section right here, what happens? It's going pretty fast, but which direction is it going now? Which direction is it going? Back. It's coming back now, right? This point, it's where it turns around and starts coming back to the start, wherever it started. It's going pretty fast back towards the start. It's now stopped again. Somehow it stops for some reason. And then it continues on back and eventually arrives back at the start. How does the boat's motion there compare with the boat's motion there? If you compare the slopes of those two, first of all, they're both going downhill. Going downhill means it's either coming back or it's, losing something. The distance is getting smaller here. It's going faster there than there. Okay, when you talk about its speed. So if you describe something like that, that would be good. One difference here with this graph is now this is a speed time graph. When you look at a speed time graph, it's going to make a difference. Don't just automatically assume, okay, straight line, I know what straight lines means. It means the boat is stopped, right? This is a speed time graph, so when the line is going up what does that mean is changing in this situation? When the line's going up, what's changing? Yeah, whatever this is. The speed, the rate that it's going. This would be, now you may have talked about this in science, the slope of this is not speed because the actual numbers are speed. What is the slope of this graph called? It's the rate of how this is changing. What's the rate of change of speed called? What's it called? You've learned this in science yet? What's it called? Starts with an A. It's called acceleration, right? Here it's accelerating. It starts out at, what's its speed at the start? Starts out at 0, right? Starts out at 0. Speed is increasing, and then what about this part up here? What happens at that point? When you have a horizontal line on this graph, does that mean the boat has stopped? Doesn't mean the boat has stopped. It means it's maintaining a certain speed. Whatever this number would be here, 5 kilometers an hour or knots or whatever you're measuring your boat's speed in, it's a constant speed. And then what happens in this section here, this is pretty steep, downhill. So what does that mean? It's losing speed pretty quickly down to what happens at that point. The boat is stopped. When it hits down at the bottom here, the boat is stopped because this is a speed graph. It stops pretty quickly, right? Because it's going that speed all the way down to 0. Then it starts back up to that same speed again, stays at a constant speed for a while, and then what about this last part here? Is it rapidly decreasing speed? It's more gradually. This is more gradually decreasing speed because the slope is not as extreme here, right? The steeper a line is up or down, the more rapid the rate of change is for that quantity. Second thing here is, second example here is about growth of bacteria if the food supply is limited. Okay, so this says bacterial growth if the food supply is limited. What would the graph look like, do you think, if the food supply of bacteria was unlimited? Why do they have to say that for limited? What would it look like if the bacteria food supply is unlimited? Well, first let's say if this was a graph of bacterial growth with unlimited food supply, this is time down here. This is number of bacteria. See time, number of bacteria. So if we had this graph here where it was time and number of bacteria, what would the graph look like? Can this graph start right here? Can it start at 0? At 0? Can it start at 0? You know enough biology now to know that the answer to that question. Can this graph start right here and go up? Why not? If you have no bacteria at the start, if you have absolutely no bacteria, if you have something that's completely sterilized, there's no bacteria at all, can you have bacteria eventually? Unless one arrives in the situation, but probably more likely this doesn't start at 0, it starts up here somewhere, right? You have to learn that the place where the graph crosses the vertical axis is the initial value of whatever it is you're talking about. It has an initial value here of something. So this graph has an initial value that's not 0, this has an initial value that's not 0, and this does too. The initial value is not 0 for any one of the 3 graphs there. But that could be something you use to decide which one's the best. If the bacteria's food supply was unlimited, what would happen? It would increase, and what would happen? Would that ever change? You might not know whether it looks like this, or it's straight, or whatever. Actually, bacterial growth doesn't go straight like that, because the more bacteria there are, the faster it's going to be. It actually ramps up like that. But as soon as the bacteria's food supply is limited, it's not going to look like that. Could it look like this? Could it continue to increase forever? No, it's not this one. If you're trying to explain your choice, this shows that it increases indefinitely. It can't be that one. Could it be this one? What would this be saying about the growth of the bacteria right off the bat? It goes down right away. They don't like the food they're given, and then they realize, well, we better eat it, I guess. What is it saying? Goes down means what in terms of what's happening with the bacteria? They're dying. The bacteria are dying off, and then they realize, I don't know. That's not it, right? This can't be it. They're not going to die off right off the bat. They're going to increase, but they're not going to increase indefinitely. I guess this takes them a little while to realize that. Takes them a little while to start splitting into two, right? And dividing. What happens eventually here, though? Why does that happen? What is this flat section? What happens there? Why does it not continue to increase? There's so many bacteria, and what happened? They ran out of food. Why doesn't it start to go down right away? As soon as you run out of food, do you die right away? No. A little while goes by, then you start to die off, right? So there's a section where they have no food, so they're not increasing, but then they start to die off at this point. So, I mean, all of that could be explained there. I've explained it verbally, but there's this question here which asks you about making the best choice between those four things. At the risk of, this one's a little harder to decide, right? Because the graphs are more similar to each other. Now, there's one criticism I have of all of them right off the bat, and it's the first thing we discussed about these. What was the first thing I discussed about this when we were talking about this? Along the vertical axis, that's the first thing you should look at about a situation. These all had a what you call a y-intercept, a vertical intercept that was not 0. That means the starting point was not 0. What's the problem with all four of these graphs when you look at it? If you think about the situation, what's the problem with all four of those graphs? No, I'm just talking about the vertical axis. Forget about the line. Just look at where it starts. Where does this one start? 0, 0. They all start at 0. Is that true? If this is the day you're born, do you start out being 0 centimeters tall when you're born? You definitely do not, right? If these graphs were more accurate, what should they be? Where should they start? There's no numbers on these graphs, but you can still interpret that probably it should start up a bit higher and then go down. Does that make sense to you? Probably all of these should start up a bit higher and be the same shape, right? Does that make sense? It's pretty important for you to know y-intercept is the initial value, okay? Y-intercept is starting value or initial value. Sometimes you call it the starting value, sometimes you call it the initial value. Okay, so that's a concept that's worth knowing in this whole chapter, right? So let's pretend we're ignoring that, okay? We're ignoring that for now, the fact that they should start up higher. What would each of these graphs mean about this situation? So you start out, what's happening with your height for the first section of this graph? Increases at a pretty fast rate. And then what starts to happen? Suddenly you start shrinking. The day after you stop growing, you instantly start shrinking. Does that make sense? Doesn't make sense, right? You think it does? Do you grow at a steady rate from the day you're born? Like for the first part of your life, do you grow? Should this be a constant rate? Here's another concept that you need to know. Straight line is constant rate. Do you grow at a constant rate from the day you're born to whenever you stop growing? Definitely not. This is a constant rate. That's one problem with this graph. You don't grow at a constant rate from the day you're born to whenever you stop growing, right? When do you do your fastest growing? Much before that. We're talking height here, right? We're not talking anything else. When you're born, you might be 20 centimeters in height, even though they call it length when you're born because you're lying down on a bed always, right? You might be 20 centimeters in height. That's pretty short. I mean 20 inches. You might be 20 centimeters, possible. You might be, after 6 months, how tall might you be? 40 inches? 6 months, what has happened to your height? You've doubled your height. When you're 10 to when you're 10 and a half, do you think you double your height? Yes, you double your height, because you might be 4 feet tall when you're 10 or 4 or 5 feet tall. You definitely don't double your height. It's not a constant rate. It's really important to know that a straight line is a constant rate. The graphs with the wakeboarder's speed, right? Boat's traveling along at a constant rate. That makes sense. The boat is traveling at a constant rate. It's not going faster or slower. Your rate of growth is definitely not. This is definitely not one of them. Let's look at this one next. Because here we don't have a constant rate, but what is it saying? If you look at the first part and you look at the second part, how do the slopes compare there? Where's the fastest rate of change? First part or second part? Which rate of change is faster? Definitely the part that I highlighted in blue. The second part is faster. Does that make sense in this situation? No, you don't grow faster when you're 10 or 11 than you did when you were first born. We need a graph that is, so it's not this one. Plus that has the problem of it instantly starts shrinking again. So it's kind of between this one and this one. That's the decision you have to make. Which one do you think is the better one to represent it? B. Probably B. Why would it be B? I agree with you. Why would it be that one?
It's not like you immediately start shrinking.
It's for sure. You stay the same for a while. Absolutely. You stay the same for a while. And then you gradually start shrinking. The other ones are more dramatic. And there's a couple of things, subtle things we could say about this one. What about that first part? Does that still have the same problem as this one did? It still looks pretty straight for the first part here. It looks fairly straight. And that's saying you're growing at the same rate for the first part. Why is this a bit better? When are you growing your fastest in this? At the beginning, and that makes the most sense, right? Okay, so that's a lot of reasons there. I didn't write them, but we discussed them.